Let me get this. Darn things. With that wide angle view.
I think I've ever seen you move so fast.
What?
I don't think I've ever seen you move so fast.
You should see. You should see me in Arizona.
See you what?
You should see me in Arizona. I was everywhere.
You said it. You see me in person. Right.
Okay.
Happy.
Video. Already. Welcome, everyone. Hello, hello. Can you all hear me? Is my audio good? Sanjay, can you hear me? I can't hear you for some reason.
Oh, you cannot hear me?
Oh,
Hello?
no, now I can hear you. There you go.
Okay. Yeah.
Okay. So I I uploaded a video more like a pre-lab tour, and then
Mhm.
while that pre-lab tour is priming everyone for the live, I'm gonna go suit up at the clean room in a couple of minutes. So I don't know when you want me to play the video. Uh, Let me know. Oh yeah, my camera. I almost forgot about it. So right now I'm using my tablet camera, my Surface camera, but then I have a 360-degree camera that I would use in the clean room for the next session. So that's this device right here, and it's supposed to be able to like scan everywhere in the clean room. But I will simply use this as a wide angle view because, well, it's a little difficult to do interactive 360 on here. So, and the microphone right now is actually hooked up to this thing on my ear. But yeah, if we have any issues, you'll let me know. Then maybe I'll be able to see it in the chat. Okay, so welcome everyone to the live session, and my name is I'm your speaker. My name is Henri J. Bernard, here at the University of Minnesota. And this lab tour is going to be, it's going to consist of multiple components, but there's going to be a lot of footage. I'm going to have sort of a pre-session that's going to have, that's going to show what the lab is about, and it's going to give you sort of a sneak peek. And then I'm going to go, like I said, back into the clean room, and then I'll show you from this camera here, this other camera, what it looks like from the inside. That's what we're going to do. And then let's see what else. If there are any questions in the live session, just send them to me on the chat or something, and then we'll do that. Yeah. And everything, of course, is going to be recorded. It's going to be uploaded to the different platforms that we are connected, like YouTube and LinkedIn. So you can feel free to do uh, your, your typical activities, and then you can come back to this afterwards. Yeah. And then let's see, something else I might mention. I think that's all actually. Good. All right. So I'm going to go ahead and play this video, and then we're gonna continue on. All right, so we are about to enter the metal thin film laboratory, which is one of many laboratories that we will visit today. This one in particular focuses on the deposition of metal thin films and metal alloys for quantum technologies and classical technologies alike. The research can be performed on the metal thin films themselves, such as quantum materials, or the research can be performed on the devices which come from the deposition of such thin films. In a moment, I will activate the 360-degree camera, and we will be able to see a wide-angle view of the vacuum chambers and the control components for the vacuum equipment. Now I will activate the 360-degree camera, and you will hear a beep. This will give us a wide-angle view of the laboratory. What we're looking at here is one of the vacuum pumps. This vacuum pump can be placed in series, and if you want to get relatively high vacuum out of a vacuum chamber, then you can suck out the air from the chamber using a very big pump like this. So, what we're looking at here is a magnetron sputtering chamber. This is a vacuum chamber that's been installed with an arrangement of electron guns. So these electron guns are very similar to the electron guns that you would find in an X-ray machine. So this electron gun arrangement here has to be water cooled. So these metal lines here are actually water cooling lines. And then it has a high voltage source being sent to the cathode inside of the chamber. And what this arrangement of electron guns does is it essentially melts a piece of metal. So there are pieces of metal, like one piece of metal for every electron gun. And then you can aim the electron gun and control it with these control components here in the back. And you can program it or semi-automatically control it so that you could melt a specific metal for a specific amount of time. And then you can use that to create thin layers of metals on top of each other, which is deposited typically on a substrate. So the substrate could be like a silicon wafer, and that would be placed right there in the center of the chamber, as you can see in this little window. And then you can also store the silicon wafers on this side of the chamber, and we call this like a cassette. So that's what this chamber does, and that's what it looks like. There's a similar chamber on this side with the control components here. This magnetron sputtering chamber is what we call a facing target magnetron sputtering chamber. And this one has more moving parts. The one on this side does not have as many moving parts in it. However, this one has robotic components in it. The cassette that holds the silicon dioxide substrates or magnesium dioxide substrates can be placed here. And then the robots can allow you to exchange or move around the substrate inside of the chamber so that you can deposit a thin layer of metal, even one atomic layer of metal on top of such a substrate. And then you can do this over and over again if you want to create a very complicated chip for research purposes. And so that's what the metal thin films laboratory looks like. Thank you. Now we can actually move on and go to visit a clean room. Okay, so we are in the clean room right now, and I'm wearing the clean room setup. I got my clean room suit on. So this is the electron beam lithography system that we have. This setup here is typically used for leveling the sample holder. You have laser components and all that. And then we also have the electron beam lithography system,
which is featured in one of the GitHub repositories that I created. And then these are the sample holders for the chips. And then you can also place a silicon wafer on top of the sample holder if you wanted. So this is one of the silicon wafers here, just a bare substrate. If you want to see it again, that's the bare substrate. So there you go. Okay, so let's move on. This is the control system for the electron gun, and we also have like a bunch of other setups that is very similar to this scanning electron microscope. So the scanning electron microscope, of course, we use this for inspecting the samples, and this one has cryogenic components on it for extracting moisture from a sample in case the sample has some tiny microscopic amounts of moisture, and it makes the image a lot clearer. It improves the resolution. Maybe not resolution, but some other. It gets rid of the moisture if the moisture is a problem. And of course, we have storage bins, things like that for the different kind of resists. Like this one's dedicated to e-beam resists and solvents. And then we have a number of wet benches. So this wet bench here, we use it to spin coat the thin film, a very thin coating of like an e-beam resist and something similar to whenever you're performing nanolithography, you can perform that here on this machine. Okay, so if we move on to this side, this of course is where we do the sonication. This is a sonication chamber to perform liftoff, so that way we can remove the excess resist material and things like that we don't want from the that we don't want on the chip. So this is our clean room, and then we also have an atomic force microscope on this side of the chamber, on this side of the clean room. Okay, so that should be good enough for this side, and then we're going to go ahead and move on to the other side of the clean room. So this, of course, this setup is for performing laser lithography. So this is where another direct write lithography system that we have, but of course with laser you can only get micron scale resolution or a couple hundred nanometer resolution, but it's not quite, you'll never reach 100 nanometers with this particular laser lithography equipment. So, however, it is fairly decent for obtaining a device for quantum properties. So if you want to create a quantum device, you can create it with this device, with this machine setup, and that's also possible. And then we have some other mask lithography systems like this setup here, and this is the the mask holder for the lithography system, and we can expose the ultraviolet light here. So this is just one such example here. And of course the wet benches, similar to what I showed you before. Okay. Hey. And this is one of our deposition chambers. This is primarily for depositing electrodes on the device, and perhaps if you want to create some other novel or new kind of thin film, custom thin film, you can do it with this chamber, but the control is not as precise as you would get out of a dedicated laboratory. So this is not necessarily dedicated to depositing the thin film stack for a regular device. this has a limited number of materials that it can deposit it on it, but this is it does have a selection of metals like pure gold. So we do have some chromium here, for example. I'll show you. This is one of the chromium sources we have. And then we have some sources for gold as well. Let's see, is the gold? Yeah, the gold is typically inside of the chamber. It's like a pure chunk of gold. But yeah. Now we have solid iron inside of a box. Maybe I can show you. I have a tripod here, so I can open it. There's a solid chunk of pure iron. And you can place that inside of this chamber if you want to deposit material onto a substrate. So that's also possible. This does something very similar. And I think there are some public YouTube videos that show setup similar to this one as well. This is what we call an AJA sputtering system. This chamber here, this is what we call an ion mill. So we have an ion source situated here, and then the ions, we fire into the chamber, and then the vacuum chamber has a sample, and we can slice into the sample using the momentum of argon atoms. So we can ionize the argon atoms and then fire it at a substrate, and we can slice into the material very slowly. If I could show an animation of that, that would be great, but probably not today. I will try to work on something to animate that in the future, but for now, we'll have to leave it to the imagination. So it's just a beam of ions. Think of it as a beam of energy sort of slicing into a substrate, except that you can slice into the entire substrate over a large area rather than focusing it on a specific area. So like if you had a laser beam and you wanted to cut into some material, then it would be like a focused beam. But this ion gun, this ion grid that's being fired into, allowing you to fire argon atoms into the chamber, is more like a wide beam. So it's a large beam that goes into the entire chamber. So it allows you to give some amount of control over how much you're cutting into a material. So that's what this whole setup is about. We have something similar here. This is what we call a plasma. This is more like a ion plasma based etching system. So we call it reactive ion etching system, and it has a number of gases that you give it some energy with a high voltage, and then you can try to react with the sample, and then it'll etch into the sample. But this is a little more complicated to use, but it's still one of the many options you can have. And now we have some other equipment here for performing deep ion etching, or more like some sort of experimental deep etching. And then we also have another. This is one of our new equipment, but it's more dedicated to the sputtering. It's very similar to the other AJA system, except that this one has more sputtering guns, you would say. So the guns are located on top of here, and you can place multiple metals, and you can also sort of do a kind of co-sputtering, if I'm correct. And then this is where our liquid nitrogen is located. So we want to fill up liquid nitrogen, we can place a thermos here and then refill it into the chamber. And then we have another setup here. I don't use this equipment. I believe it's used for growing some kind of crystals, but that's what the setup looks like. Okay, so now we can exit the clean room. We will move on to the next clean room, and we'll have a look at some of the other thin film patterning components there are. So stay tuned. This is another one of our laboratories that we have. This one is dedicated to the testing of the material properties inside of a magnetic field, high magnetic field. So this is what we call a PPMS, or physical property measurement system. And it does have a very powerful magnet in it that can be cooled down to about 4 degrees Kelvin or so. And you can place the probe inside of this part of the chamber, and then the probe will send a tiny chip sample inside of the chamber. And then you can record whatever it is you need to on the setup. And of course, this is just a preparation area for placing the sample into the chamber. Okay, now we can move on to the next laboratory. So this laboratory is dedicated to testing out materials, or testing out mostly devices. So you can actually apply these metal probes. There are tiny needle probes here on this testing stage, and it allows you to apply a specific voltage or current to a device, and then you can also control the magnetic field and apply the magnetic field using these electromagnetic coils. The magnetic coil can be placed in this configuration, horizontally or vertically. And then the setup can actually be programmed using this computer here. The computer has LabVIEW software on it, and then you can use that to automate the testing of the devices, or perhaps even a bare chip sample if you want. Or if the experiment allows you to test a bare chip sample, you can do that. And then on this setup, I showed this in one of the Quantum Grad lectures, where you can program the computer so that it can extract the testing results in real time from a device. You can actually probe the device on this testing stage, floating testing stage, and then you can also apply it with a radio frequency pulse or microwave pulse, depending on the needs of the experiment. So that's what this testing setup does. All right, now we can move on to the next segment.
Okay, so now that the video is done playing, I can finally move over here, and right now we are live. I have the camera in my hand. I'm set up. I'm using a different clean room suit, of course, and you let me know if the audio is still clear. Is it good?
Yeah, this is good. All good.
Sometimes it's kind of overpowered. And then I'm gonna press a button on this camera, and I should be able to swap between different view modes, either the front or the back. So I think this one's a bit cleaner than the other one. You can see I'm using the tablet. So, okay. This, of course, this is what we call the gown room. This is, we have little spaces. So my name is right here. This is where I keep my stuff. It's just a spot where you can store your suit. So if you have a suit and you need to put it on, then you know where it is. You have an assigned suit area. This is where it happens. And then we have a little station
We have two stations, one right here, and then we have another one on the other side of that door there, where we can basically clean our electronics. So if you bring electronics into the clean room, like your laptop or phone, you can actually clean it before you take it in, because sometimes your fingerprints or your like oils on your skin or something could get on the electronics on your screen, and then you bring it in, and then you kind of contaminate your experiment like that. But in order to prevent that from happening, you can use these supplies here to clean things up. Yeah. And if you don't have glasses, of course, safety glasses, you gotta wear at least some form of eye protection. Yeah, and then you can actually use this computer to control equipment inside of the clean room without even walking inside. That's just such an option. It's not necessarily a requirement, but it's just one of those things. So we will actually move on to the, I guess, next section in a number of minutes, and then we'll get going. Actually, let me check on something really quick, and I will walk into the main area of the clean room. Yeah, little room area. Okay, so let's go this way. So we have some lithography bays, and then we have we had various sections of the clean room. Actually, this part of the clean room was more like dedicated to uh, the deposition. Again, this is sort of a section of the clean room that's somewhat owned by by my research group. So we can go inside here, and we have a number of equipment in here that allows us to automate the deposition of the metals. So very much like the deposition equipment I showed in the video earlier, we have this one, which is dedicated to the metals as well. Except this is in the clean room, and we can also program it with this software on this computer here. So it's actually very convenient. But if you learn how to work on something like this kind of equipment for like doing quantum materials research or working on the quantum devices, then you can learn from beginning if you want. That's if you want to go that far, then that's possible. So this is what you're looking here on the floor is vacuum pumps. So yeah, we got vacuum pumps everywhere. Anytime you see someone doing thin films research or thin film technology for quantum or thin films for even semiconductor technology, they will have some form of vacuum chamber, like or vacuum components like this that goes to the chamber. So and then we have all the gas controls. It's pretty neat. And then all I have to do is press this. It'll be on my way. So this clean room, this part of the clean room, of course, we have equipment for doing the physical vapor deposition of some things like silicon nitride or silicon dioxide. So basically, electrode control is all based here. The electron gun controls here. So this is somewhat semi-automatic control of the deposition equipment. This is less automated than many of our other equipment. Of course, you can try to use this to automate the process if you want, but That's a more of an option. And then this one here is another one of our metal deposition. So we want to create a some other kind of device using a different method that requires maybe um, precise control. You want to learn it on your own. This is one way to do it. This is less automated, as I mentioned. A lot of manual control. And then this chamber currently is running. So anytime you see this kind of deposition chamber here, this is it's got basically an O2 clean process running right now. And so that's plasma. You can see white plasma inside of the chamber. That's depositing the or actually cleaning the inside of the chamber using O2 gas. Cryogenic refrigerators. Someone is asking about that. So in this clean room, we don't have cryogenic refrigerator. If you want to go visit a cryogenic refrigerator facility, you have to go to the physics department. So right now we are in the electrical engineering department, and we don't have cryogenic that many cryogenic components or equipment in this facility. We do have some upstairs, but that's primarily for the material testing. And then if you want to do the cryogenic testing, you have to have special access to a different facility in a different building. But I believe there is plenty of footage online available for viewing some cryogenic device testing facilities. Yeah, they're not too much different. It's just they have a chamber and it's about twice as tall as this one. There are some that kind of hang from the ceiling, and then there's a magnetic. Some of them have magnetic superconducting coils inside that can apply a very strong field to a device, and then they can try to uh, test the device performance in that chamber. That chamber is, I believe, the second or third floor of the physics building, and that facility is run by a different group, which I don't have access to, unfortunately. So we can't see that one today. They work on the what is called Majorana based qubits, but they don't work on processors. But that not necessarily the qubits themselves, but the majority of the research that they do is on the quantum materials, topological quantum materials, and trying to explore Majorana fermions. So that was a research group that I worked at in the past. I don't work there anymore, but that's that's worth looking into if you're really interested. That's run by Professor Vlad Pribio. Yeah. And here's another clean room, of course. We can see everything. I mean, if you want to go inside, we can go inside. These are just probe measurement systems. You want to tap on the device and do something similar to atomic force microscopy, then you can use that there. But it's not as extensive, I guess. Oh, I just realized they replaced one of our atomic layer deposition equipment. Interesting.
see.
Let's put that there for a moment. Oops.
Mhm.
And we should have a wafer dicing saw here.
Where'd it go?
There we go. I'm trying to find something while I'm simultaneously doing this. Let's see. So if you are doing lithography to create the quantum devices, then you could create a photomask similar to this one. This is for tunneling devices. If you want to do quantum tunneling, create a device that does quantum tunneling, you can create such a photomask like this one. You can't really see the features, of course, but you could with a microscope. I don't think the 360-degree camera is going to be able to allow you to see this. We can try. Nope, the optics are not good for that. Anyways, I think that's a good enough session for today. I've showed you pretty much most of what I wanted to show you for today. This is just, I would say, what I primarily work on is the devices themselves. I don't do testing. Testing, I'd like to get into at some point, but not right now. There are some other researchers in the group that focus on the testing, and they only do testing. There are some that don't do patterning at all. They give that job to someone else. That's in that case me. So you want to learn how to do advanced direct write patterning, then I can train you or something. If you come to the University of Minnesota. Okay, so I don't know what other questions. I don't know if people have questions or Sanjay has got something to say. I'm here.
Um, I don't think so. People have much questions here.
Okay, that's good. Yeah, it's a decent session. We got like 40 minutes. 40 minutes in. And this camera's like zooming in and out of it.
Yeah.
This thing has a mind of its own. It's nuts.
Yeah.
But yeah, this is my life right here for the time being. I typically train people in here. I've trained about 13 or 14 students, PhD students, and a couple of postdocs. I've trained them in this laboratory and in some of the other facilities.
that we visited. Yeah. So I'm relatively young,
So,
but I'm like I've been doing this since I was an undergraduate. So yeah, it feels a little odd for me at times, but yeah, that's how it is.
so, so this university has two labs, right? Like this, or
We have two clean room facilities here, and then
Mhm.
in the next like 1 or 2 years or something like that, we're supposed to have another facility that's dedicated to quantum spintronics, which is our for our group. And then that one is a bit more, it's more industrial scale because we want to be able to pattern and design and create all kinds of new nanomagnetic devices for the quantum research. And then potentially we could even use that to upscale, demonstrate the manufacturability of something that I'm working on, which is a magnetic qubit. It's a metal based magnetic qubit structure that I'm working on. So that's my work. It's never been done before because like it's the devices that we have is all spintronics based. There's no we call it doesn't rely on the semiconductor components. It's all metal. That's what it is. But yeah,
it's good to see, yeah, it's good to see all the labs and everything. It's pretty like interesting to see how the equipments are there and everything, and how you guys like go into the clean room and everything. It's good.
yeah. And this thing is, I mean, it's just running 24/7. So if you're like me and
Oh,
you're awake all the time, you just come here any hour of the day or night. Don't ma- don't matter. Of course, people, most people here that work here, they have like families and all that, so they have, they go home, like they stop working at 5 p.m. sharp, and then they run home. Yeah, but me, I'm everywhere, so I'm just here all the time. Yeah. So I got the opportunity to work on like maybe 30 different equipment. So I'm
oh,
certified on like 30 different machines uh, for in the laboratories. Yeah, yeah. But anyways, it is. I mean, to me, this is fun. I think some people they like the clean room more, and then others they don't like being in the clean room. So it really depends on how you experience the clean room. Some don't like it, others do. Yeah. So you have to see for yourself. You have to experience for yourself, and then you'll be
mhm.
able to decide whether or not being in the lab is for you. Yeah.
Maybe someday we should have a career session. Like if people are interested into going into this domain, where they should start and how they should go, we should have some like one career session, like as an
Yeah.
advice session. What people want to do, if people want to do the work that you are doing right now, how they should proceed and everything. We can have a one career session, because I know a
Yeah.
lot of people like love to know like how you went to this path and what all hurdles you have and what all exams you gave or anything they want to know. So maybe we can schedule one and see.
Did you say exam?
Yeah, like people want to know like how to get into this university, if they want to give any exams or anything. People are just
Uh,
curious to know.
I would probably forward that to somebody because I've never, personally speaking, I've never taken an entrance exam in my life.
Oh yeah.
Yeah. So for me, that's my ex- on that part, my experience is a bit more unique because there are some things that I bypassed based on certain factors, like the things that I worked on in the past. Like I used to do electric vehicle research. I used to be in that area,
Oh,
and then before that, I was a carpenter. So like carpenter, electric vehicles, and then from electric vehicles, kind of explore around like physics, nanotechnology, and then I got into quantum. So yeah, it's
Now what's
but
the next?
yeah. So now I'm just in leadership at the moment. So now I'm just like leading a team of quantum hardware engineers. So I'm trying to like actually I'm going around the university having one-on-one conversations with people that are either PhD level or undergraduates, and then they they're interested in quantum is about, because quantum is not as big here at the University of Minnesota as far as like the when I say quantum I mean like quantum computing, but quantum materials I think it's pretty solid here. There are some people they work only on the material science side of things like solid state or condensed matter physics. They're really interested in that, so that actually takes the majority of people who do quantum here at the UMN. And then a smaller population, which I'm a part of, is working on the like using it for quantum information stuff like that. Yeah. So, but I'm trying to expand that. I think there's a big opportunity. I mean, this is a big university. This is uh, like number 6, or at least when I came here, it was like the 6th biggest university in the whole U.S.
Oh,
Yeah, so it's pretty big. It's like a city. It's
yeah,
like a small city when you come to this university. Yeah. Yeah.
but I think yeah, this lab tour was informative for a lot of people. So and yeah, a lot of people can see the replays and everything, and they can reach out to us if they have any questions. But yeah, overall it was a good experience.
Yeah. I mean, I think some people they send me questions about how I use the Qiskit metal for making a quantum device, because you've seen the GitHub maybe, or maybe you've seen the post I made about it. So like
Yeah.
I went and did that. I created the repository to try to behave like a tutorial. And then if you have any cleanroom experience, then you even can use laser lithography to try to create that device. Just kind of make the file a little bit bigger, adjust the file, the design size a little bit, and then you can import it into the design process flow for the the equipment inside the cleanroom, and then from there you can create your own quantum devices. Yeah, it just requires that you have to deposit some thin film material. Could be metal, semiconductor, depends on what you want, but you could do that. There's this thing called Q components in the Qiskit metal library where you can like design your own custom, make your own custom design of the device, and then you can extract that from Qiskit metal and then bring it to the clean room and then upload it and then basically print. It's like you're 3D printing a quantum device. So it's like so many possibilities. But yeah, I'm trying to make a video about that on YouTube or something, maybe on Quantum Grad or something. But I there is an article I finished that I'm supposed to upload to Quantum Grad on the fabrication technology and all. That was finished like last year, but there's something on there that I wanted to add, but I never got around to it at the very end. So I'm hoping to get back to that in the coming days. Yeah, these days I'm like presenting stuff all the time. So I have a big I have I have a big presentation coming up later this evening, and then there's another one. There was 2 more big presentations I gave in the previous weeks, which is on the quantum, the qubits control hardware, and also for like the fault, like the hardware that's slowly moving towards like tolerance,
Mhm.
quantum computing era that's coming, that kind of stuff, and then like the million qubit control components, the quantum FPGA stuff like that. I I went ahead and made a big like 3-hour presentation on it, so I had to split it up into 3 series.
at the in the research group. So like, yeah, even the physicists, the PhD physicists, are there with me, and we're like, I show them uh, how we can approach it from our perspective using spintronics, stuff like that. So yeah, that's what I'm up to at the moment.
That sounds all interesting to see, like these presentations and all. And it's like pretty exploratory field right now, and a lot of people are
Yeah,
experimenting, so it's good.
yeah,
Yeah,
definitely. And
yeah,
it seems like the more you do something, I mean, even just clean room work, doesn't have to be too intensive, but you just kind of constantly go at it and publish things and talk about it in public, and then like that's it gives you more flexibility at the end, and then you're kind of given the choice to pretty much do what you want. So if you feel like doing any like specific uh, quantum hardware work, for example, then you can focus on that, and then like you'd be the leader in that area. You'll be
yeah,
the world the world's leading expert in a specific area after some time. It takes like mm, maybe 3 years or something after getting into it. But that's what I noticed.
yeah.
Like even as an undergraduate, that they give you flexibility after some time. Yeah.
That's great.
Someone asked a question. Says quantum. Do we have any quantum machine learning application
Yeah,
session coming up? Oh, I think that's for quantum grad in
yeah.
general.
I think maybe we have to like plan for QML and everything. So maybe coming soon, I can say. Yeah, there's a lot of interest in quantum. So this quantum hardware is some of the like gray areas where a lot of people doesn't talk about. So this is like one of the interesting part. Because the quantum hardware, like a lot of people know about quantum algorithm, they want to do software stack and everything, but a lot of people doesn't know about quantum hardware then. So it's good.
Yeah, yeah. And the clean room is inseparable from quantum hardware. So
Yeah.
that's today's session.
Yeah. And then yeah, I think it was overall a great session, and yeah, we'll connect with in future, and we'll have more sessions. Yeah.
Wonderful.
And yeah, yeah, and thank you for the time and everything. Okay. Yeah.
Oh, yeah, yeah.
Yeah.
All right. Well, thanks everyone for tuning in.
Yeah.
This 1 hour session, almost 1 hour.
Yeah.
Yeah. See you next time.
Yeah. Bye bye.
Cheerio.